today's agenda, we're going to be looking at the relatively new Composite Layout Manager within Femap. There's some new features like linking layers when you duplicate in the Apply Material Manager, along with we'll take a look at the Global Apply Manager, how that works with linking continuous applies and post-processing and viewing these global apply models. We'll also take a quick look at some useful custom tools, APIs that help make selecting various plies a bit easier. So real quickly, a layup is the Layout Manager manages the stack up of multiple composite plies. Ply has some of the following attributes: ply type, referencing, what it might be referencing, material, thickness, angle, and there's some additional attributes you can enable by right-clicking on the column headers. That is, and you can turn on Global Ply ID, an on-off column for turning on and off different plies, and enabling any sort of per ply basis failure theories. So over here on the right bottom here, we have a screenshot of the previous layup editor here. You can see most of the buttons, all the buttons had text on it, but now we've moved to this more graphical one with graphical icons instead. They're fairly intuitive, but you still kind of got to learn what they are. But one of the advantages now of the new Layup Manager is this ability to link. We'll talk about that in just a moment. But when you want to copy and duplicate plies, let's say you've set up the half of your ply and you're just going to mirror it because that's what your ply is just mirrored on one side. We've got a variety of different ways to do that, and not necessarily if they are mirrored. So for example, match order here will copy the plies in the same order as the original order in the layup. We've got symmetric here, which will paste the plies in the reverse order, so that mirror that I mentioned before. And then there's anti, which will do the same as match order. It'll paste it in the same order that they were copied in, but it'll actually reverse the angles that the material is oriented in. So it'll flip from positive to negative or negative to positive compared to the originals. And then there's anti-symmetric, where it combines both anti and symmetric. So what you do is it'll end up pasting the plies in reverse order, so the mirror image, but it also will flip the values for the angles. And then there's linked. So if you enable the option for link over here on the right hand side with this screenshot we have, if you enable this option here, what that does is it'll maintain a link to the plies they were copied from. So any sort of changes with the, let's say like the orientation, should automatically update to those linked plies. Also, a quick note, the above selection and below selection options depend on where you selected a column. So once you've copied this icon right here, your selected plies, you can then click anywhere you want in your layup on any one of these numbers here to then get the option to either paste above or below that particular ply. So you don't necessarily have to like copy and paste, at the very bottom or the very top of everything. You also get the Ply Material Manager here. This allows you to predefine your plies, give your plies a name, its material, thickness, and any sort of failure property here. So that way, when you're in the Layup Manager, you can just select existing ply definitions and not have to define material thickness or thickness on a per ply basis. So it makes it a little quicker in that sense. Also included with the Layout Manager is the Layout Viewer. This was present in the previous one. Not much has changed with it. It's just this graphical icon here on the right. So the upper right screenshot here, we've got this little icon with the layers and the very common highlighter button that we see throughout Femap. So this will bring up the Layout Viewer. This lets us view the orientation and the stacks of our plies. And it helps us make sure that we got everything right. Though with 13 plies, everything fits kind of nicely in our screen, but if you have a much higher count, say like 50 or so, this might get a little bit difficult to determine the orientation of each ply. So you can just move this scale here to kind of zoom in till it's visible, and this bar right here will help us move up and down through the stack. So if you have zoomed in a bit or not, you still got the copy option here. This will copy a picture of this into the Windows clipboard. And if you have zoomed in a little bit, there's the visible only option. You check this and you'll see you only get a screenshot of what's visible in here. If you deselect that, you should get an image of the entire layup. So global ply IDs, they're used to designate a single continuous ply in a model. You can have multiple global plies. However, you could only apply the ID to one layer and layup at once. If you've specified every layer as a global ply ID, Femap generates a pCompG card instead of a pCompP, and the grid point or the global ply ID results are generated by Simcenter Nastran. There's a couple ways to get to the global ply manager. In the model info tree, you can right click on layups and get the global ply. You can go to the menu options for model laminates global ply manager. And then if you're in the layup manager already, you've got the little icon right here. Again, kind of intuitive. It's got a picture of the globe. Click on that to get to the global ply manager. So one of the advantages of the global ply ID is it helps us link continuous ply from one layup to another layup. Quite often we'll have layups where there are additional reinforcement plies, and they therefore affect the numbering organization of our plies. And so the continuous ply helps us link these, or this global ply IDs help us link these continuous plies. So for example, here in our screenshot in the lower right, we've got layup 1, layup 2, and layup 1 is just duplicated on the other side. So it's fine with global ply ID 1, ply 1, it's the same ply on all layups, but when we get the global ply ID 101, in layup 1 it's 7, but in layup 2 it is 9. So that just helps us link across this because there's a couple extra reinforcement layers in here. And we don't just want to go straight across like this because ply 7 in layup 2 may not even be the same type of material in orientation. So our results might not make a whole lot of sense when we're looking at global ply 7 because we're looking at, or when we're looking at ply 7 results, because we're going to see different plies with possibly different material properties, different orientation. And so it's similar here with the ply 2, global ply number 2 on plies 13. Again, it just links our top outermost plies together. Even if you haven't assigned any sort of global ply IDs, you still get the, there's still the top ply of layup and the bottom ply of layup that you can quickly access in the post-processing toolbox. You don't have to have figured out your global ply IDs before your analysis. You can always go back in and change things afterwards or add global ply IDs afterwards and then find them in the post-processing, but we'll show that in the demonstration here shortly. We won't be covering too much else with the in post-processing of laminates. There's already an existing video that Dan Nadu has done. It's a very good video. I highly recommend taking a look at it. You can check that out on our YouTube channel or look through, or you can search for Simcenter Femap composite post-processing. I also have a link here if you feel like copying that down and putting that in your browser. Otherwise, he'll talk about failure ratios, strength ratios, how to envelope results, and calculating safety factors in the video. Some of the useful custom tools you may find for creating laminates. There's the honeycomb P-shell. Find here, help let you define your honeycomb materials. Group elements with no material direction helps you find any sorts of parts of your model that you haven't assigned a material angle definition. That way, because you don't want to have it left undecided, you don't know what it might be assigning to, and it might not be appropriate for that particular area of your layup. So yeah, just a quick way to help identify parts of your model without having to like visually scan around everywhere and looking for those global, material angle definitions. And then what I will demonstrate here is like the post-processing laminates tool. In here we'll take a look, I'll demonstrate like the next ply and previous ply. These are just little shortcuts that help you jump from one ply to the other without having to increment through the individual vector results for a ply, such as like stress, strain, etc., and the directional stresses. And so this will just jump, we'll keep the same sort of stress that you're looking at, or vector, or be it stress, strain, etc. And it'll just go from one ply to the next ply and keep that same sort of result type that you're looking at. And it also works with the global plies. It helps you increment through them. So let's take a look at a demonstration model here. I've got a very simple cantilever beam here. It's fixed on the left end and enforced displacement on the right. Material direction is already defined. Got it set to a nice bright red color. And the model has been split in half. So I got a laminate, I got a layup here for the right half and a layup on the left half. The right half has already been defined. As you can see right here real quickly. Let's just take a quick look at it. I've got 3 plies, a weave on the top, a weave on the bottom, and a unidirectional in the middle. Thicknesses and angles have already been defined, and they've already set global ply IDs. So what we're going to do is we're going to work on this one right here, which is going to be the left half of our model. Let's take a quick look at it. It's only got 1 ply in here defined, so that way we can go through here and play with it all we want. Sorry, I meant to click on that, delete, so that just kind of cleared out what we got. So define plies, pretty straightforward. We can go ply, select material. Let's just say the weave here, give it a thickness. We'll put in a ridiculous value because we're not going to be using this. We'll define a more practical one. And we put that in there. So now we've got our single ply. But let's add another ply and take a look at that ply layup. So there's a few different ways you can define plies. You don't have to just necessarily go through and manually input anything. We can go here like the ply material mentioned before. And now we just select this little drop down of already predefined weaves, and there it is. It fills out material, thickness, and we can just go in here and change the angle to whatever we want. Let's put in -45, for example. To access these ply materials, you just go up to right here. This is the ply material manager. We get this new screenshot, this new window here. To define a new ply, just give it a name. I'll call this ply demo. Pick any sort of the materials that we've already got defined. Give it a thickness. Give it 1/8 of an inch and just add it to our list. So there we go. Now we've got a ply demo. Click OK. We can go back over here. Change this. We've got ply material. We can always go back to the drop down, and there's our ply demo. Automatically filled out the material and thickness for us. Another thing we can do is we can actually, through this reference, is that we can add a layup. We can just insert in an existing layup that we might have. So let's go insert in that one layup that I've already done. It's brought in our materials and our thicknesses and angles. The only problem here is it didn't actually bring in our global ply IDs. So let's take a look at that. Remember, we got to enable it. It's not on by default. So we see here, nothing has a global ply ID right now. This layup that we already defined, the layup end or load in layup, already had global ply IDs assigned to it, but it just did not bring them across. So that's kind of one of the downsides of that particular method of it, of just inserting an existing layup, is that you'll then have to go through and redefine the global ply IDs. So let's take a look at the copy and paste functionality. So to be able to select a ply for any sort of options, such as like inserting a ply in between one, moving a ply, or deleting them, we have to select on this column right here. Otherwise, these options won't highlight. And we could always collapse this layup here too, so we don't have to see it. It doesn't have to clutter up our layup here. But let's go ahead and just keep it expand. We'll go through here. We're going to select everything. We're going to click the copy select apply. These options now become available to us. And we're going to stick with anti-symmetric. So this is just going to be mirrored, and it's going to reverse our angles. And we're going to put this at the bottom instead. And then we click the paste button. So there we go. It's pasted everything, even that existing ply, our existing layup that we had included in there, and all the angles had reversed. So we can go back through here and just be like, I don't like that angle. Let's change that to 0, for example. And that should have been updated down here. Which ply was that again? Oh, ply 7, link to ply 7. Yep, that was that one right there. So again, let's go 45 and see now it did negative 45. Mistype. Good. So let's take a look at another thing. One of the challenges of, or one of the possibilities of mistakes that can be made is with the global ply ID. You can assign it willy-nilly, so to speak. You can assign it to any ply you want. Doesn't necessarily have to be the same material or thickness or whatever. So let's take a look at the global ply manager before we start doing that. So in the global ply manager, it's pretty easy to add global ply definitions. We just give it a name. We'll call this GPID demo. Give it a material, a thickness, and add this to our list. And there we go. It's right here. So now there is an option to check this box for validate. And what this will do is it'll double check that our layups have assigned a global ply ID to a ply that has the same material and thickness. But for the moment, I want to delete this because we're going to demonstrate how to add this post analysis. We'll click OK. And so I'm going to start applying some of this a bit willy-nilly. We're going to call this uni middle, even though that it really isn't. We're going to call this one weave top, and it's got the wrong size. So if I try to click OK, it'll give me an error message down in the message window saying unable to assign global ply ID, material and thicknesses are not consistent. So it definitely creates a little problem for us here. But instead, let's just wipe everything right now and let's build our actual ply. I'm going to demonstrate one other thing. I'm going to do a load from library. I've already got a basic ply set up, and it's going to load in here. It does create a little problem in the way it works. You can see it's created more materials for me. If I try to click OK, I'm going to get that error message, material and thickness are not consistent. Because when I try to load an existing ply, it'll create new material properties or material definitions for us. It hasn't populated in the model info tree, but you can see by the IDs 4, 3, we don't actually have an ID of 4 or 3. And that's why it's giving us an error message too. It's because the IDs are wrong. Even though the material is technically the same, the thickness is the same, the IDs are the material IDs are incorrect. So let's do some fixing right here. So we got a weave top. Let's make sure we select the correct one. This is our unidirectional ID so 1, and so this one is going to go to ID 2. Just to demonstrate real quickly, now that we fixed that, we can click OK, and the window will close out. Let's go back to editing this. Let's add some additional plies. I'm going to do a ply at the top. I'm going to use our ply material. I'm going to select the unidirectional material, and I'm going to do a ply at bottom of layup. And again, I'm going to select ply material, go with unidirectional, so that it makes a bit more sense and actually does something in our model. Unfortunately, right now, what we're going to see is with ply 3 here, this uni middle, that's going to be our neutral axis and bending here, so it's not actually going to do anything for us in our model. It's just kind of a spacer, so to speak. So let's click OK. Our directions are all 0, so that makes good sense. Our model is set up. You should be able to see it right now. All right, correct. The other one is on the other end. Correct. Let's give this analysis a run. It'll finish here real quickly. By the time the log loads, it should be done. And there we go. Let's take a look at our results. We want deformed. Yes, we do. Nash train case 1. Okay. There's our deform. It's giving us a contour already. Right now it's looking at laminate ply 5, which is our very topmost ply here on the left hand side. The right hand side only has 3 plies, so therefore there's no results displayed there. So that makes fine. All right, that is fine. We're looking at X normal stress. Let's take a look at the global ply IDs. Now, when we select the global ply ID, it'll take priority over whatever ply is selected in the output vector, but it'll still show us the result type, like via X normal stress or strain or something along those lines there. So, for example, we take a look at weave top. So this will be what, ply 4 over on the left-hand side and ply 3 on the right-hand side. So we get one continuous result pattern for that. In our X normal stress, we've got weave bottom. And if we look at the uni middle, we should pretty much have no result. Yeah, because it's on the neutral axis and this unidirectional isn't going to do anything for us. So remember, that takes priority, but we can always change the result type we're looking at here. We can always click through or just go through here and select. So right now we're on ply 5. If we were to go to even apply, or we're on ply 5 X normal stress. So if we go to ply 1 X normal stress and click OK, we still see the same results because it's the X normal stress that we're looking at. It's not the ply that we're differentiating when we're selecting here. So we could take a look at Y normal stress, X, Y shear. There we go. There's some information. Or YZ shear. But let's take a look at bottom of ply. We should actually see some X normal stress. So yeah, X normal stress, we're looking at bottom of ply. This doesn't technically match our global ply IDs because this is going to be ply 1 was the unidirectional, and over here ply 1 is our weave. Let's take a look at those custom tools for the post-processing. You can see here we can increment through global ply IDs. Right now we're on, let's go to weave top. So we can go over here, post-processing, and click next global ply. So switch to weave bottom. Next. Again, should take us to our unidirectional, the middle one. Perfect. So yeah, it works great for jumping through there, but it's a bit of a slow process via clicking on custom tools, post-processing and finding. I mean, it's not much faster than going through here or changing this drop down here, especially as we get more than just like 3 IDs. We get like 50 or so. This will get pretty busy. So creating a custom tool for that will definitely help speed things up. So let's demonstrate adding a global ply ID post analysis. And what we're going to do is we're going to add this to either like the top or the bottom. So let's go to let's edit this first. Let's identify which one we want to do. Let's do the top one here, for example. Let's assign a new global ply ID to this. We don't have a new one. If we try to do weave top, we'll get error message about this. So let's go to none. And let's open up our global ply manager. Let's give this one, again, we'll just call this GPID demo. It's unidirectional, our thickness 0.0625, and add that to our list. We can check validate here too. Click OK. Should work just fine. For this one, same material and thickness. Click OK. No error message. So didn't make a little mistake there. Back to our post-processing, and there it is. There's our global ply ID demo that we've created. And again, since that's the top one, it should match the same as laminate ply 5 results, and we can see that we've got a nice little stress distribution, and it's of course not the global ply ID only is for that one ply. Doesn't go into our laminate here on the right hand side, so we don't have any results there. So that concludes our demonstration. So some takeaways regarding the new Layup manager. There's definitely a new Layup graphical there. Everything's been replaced with graphical icons, and they're fairly intuitive. The only issue with that is that you still kind of need to learn what they are. So I find myself still kind of hovering over in them to make sure I'm looking at the right one. The ability to link layers as symmetric or anti-symmetric is pretty handy. With them linked, you can always go back and modify things. The Apply Material Manager lets you predefine your layups in advance, so that way you only have to select them from drop-downs. You don't have to go through and copy and paste repeatedly or define them each and every time. My only real complaint is that I really wish there was an undo button for the copy and paste. For me, not frequently using the Layup Manager, I will almost always get the symmetric or anti-symmetric incorrect the first time, or have to sit there and think about it a few seconds to make sure I got the right one. And then obviously paste it the wrong way, and there's no undo. You just have to select them all to delete it. So thank you for watching the video.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.